Yep. Okay. Here we go. I know I lost you guys last time, so we're gonna undo that loss. And in fact, we're gonna work with this one right here so we can figure this out. So this is right here. This is the matrix. Matrix A is 1, 4, -1, -3. And we found the matrix last time, kind of difficultly. We did it by systems of equations, and it was kind of cumbersome. So A, and this little guy right here is called inverse. You don't call it A to the -1. If it represents a matrix or a function, we say inverse. So A inverse is -3, -4, 1, 1. That's it. And so this was the long way. We're good? So don't do the long way. But we had to do it because we didn't need to know where it comes from. Okay, so now let's shorten up the way that we do it. And we're going to do it like this. We're going to do find A inverse by formula. What? There's a formula for this? Mr. Ng, not fair, not fair. You didn't say there was a formula. So Joe was right the other day. It's kind of like you seem like things do move around, like signs change and all that stuff, right? But it's not just a sign change like we had in example 1. That was too easy. So what is the formula? First of all, it's only going to work on a 2x2 matrix. The formula, that's the only formula we have. So if it goes into a 3x3, forget it. We can't use the formula, but at least we'll know the formula.
If I find the formula, will I get PhD?
Yay. I don't know if there's a formula out there. How about that? Your book group presents a 2x2 formula. So here's what the formula is. If A is A, B, C, D, then to find the inverse of A, all we do is we do this. It's 1 divided by A times B, A times D minus B times C. And notice what happens to the matrix. Look at this, D, B, C, A. And this is still not the fastest way to do it, but we still need to know at least there's a formula for it. All right, if you think you got it, go for it. If you think you can set up the formula here, I'll do the formula on the next page here. So think about where is your A, what's your B, what's your C, and what's your D, and go for it. Give you a 30-second head start like that, because I think we can do formulas pretty easily. A is 1, 4, -1, -3. Eventually, we want to be sending like, let's see, I think it's 8, 3, 8, 4. Let's see if it's 8, 4 now. 8, 5. Yeah. 8, 5, we'll get into cryptography with this stuff. We'll get there. Send coded messages to each other. It'd be crazy stuff. Okay, anybody done? Done. Okay, let's jam with it here. So A is equal to all this right here. Where's your A? Where's your B? Where's your C? That's your A. That is your B. C is right over here, and that's your D. Are we good there? Okay, this is an easy one. I didn't make it complicated. So it's going to be 1 over A times D minus B times C, whatever that's going to be. And then we switch around our terms. We'll go based upon the formula on the previous slide, right? So it's almost like if you think of it, let's look at the formula here. It's A and the D switch around, is that right? A and D switch. It's this one switches with this one. And then it's the B and the C that switch, and they also change signs. That's how we sort of think about it. It's crisscross with the sign change diagonally up. Okay, we go with it here. So let's see, 1 times -3 is -3. Minus sign, 4 times -1 is -4, so it becomes a +4. This all stays the same. That's so fun. This was just a multiplication by 1. On the homework, obviously it's not going to always be a multiplication by 1. And the question is, did we get the exact same thing we got in example 2? We should. I know, let's see, let's go, because I'm going to use the same one over and over again. Here's our, Okay, here's our example 2 one. We're going to use this one quite a bit here just to get us. So yeah, -3, -4, 1, 1. We good? Last viewed is there right here. -3, -4, 1, 1. Perfect. Love it.
We just use the formula every time if it's 2 by 2.
Yes, only if it's a 2 by 2. If it goes to a 3 by 3, then we're in trouble again. Now we're like, okay, oh, hold on. This is not very good. That means if we use if it's a 3 by 3, we have to go back to our crazy stuff from Monday, right? Oh, I wonder if there's another way to do it. Okay, let's jam with it. Let's see the other way. So let's find the inverse by the matrix method. Whoa. Same thing again. Just want to see if we get the same answer. And then the question is like, why is this so important? Why do we spending so much time on these matrices, first of all, and then the inverse? Because the inverse works a lot of different ways with these matrices. Once you know the inverse, you know a lot of different things you can compute. Okay, so another process. And on the homework, I give you guys each one of these processes. So make it by systems equations, do it by formula, do it by the matrix method. Here we go. How do we do this? Here it is. Let's go with it here. 1, 4, -3, -1, -3. And then what we're going to do is we're going to set up a identity matrix on that side. That's weird. First time we have a ... straight through the middle right over here. So our job is to convert this guy right here, the left side, into an identity matrix. So here goes with the rules again. I need a 1 in the upper right hand corner. Do I have it? Yes. Awesome. Yes. Okay, I have a 1 right there. Then I leave this exactly the same. And step 1 is done. We good? That's my first step. My first step is just to get a 1 in the upper right hand corner. Step 1. Step 2 is to get zeros underneath the 1, or zeros in the column where the 1 is. Perfect. So I'm going to call it over here, and I'm going to write the new row over here. So I'm going to say row 1 plus row 2 makes a n, or new row 2. Are we good? Cool. And go with it. 1, 4, 1, 0. I'm going to forget the little ... so it doesn't get in my way. Zero, 1, 1, 1. Okay. And again, tell me if I'm going too fast because I pre-made these slides already here. So the first row stays exactly the same, no change to the first row. The second row has a new second row, which is 0, 1, 1, 1. That's cool. Good there. I run out of slides, so I'm going to recreate this one on the next slide real quickly here, okay? Okay, you guys tell me if I'm going too fast. We're good. So let me recreate it. A little too fast. A little too fast. Go for it. Boom. You don't have to write this out because this is just what the previous slide is. Now what do we do here? I need to get perfect. Yeah. So first thing, step 1 is really just to get a 1 here. We already have it, right? So step 1 diagonally down, we already have it. So now we have, let's see, I'm going to do row 2 multiplied by -4 plus row 1 to get a new row 1. Tell me if you guys agree with that. So whatever is being added to right over here is the new stuff. That's the way we always do it. So -4 row 2, add it to the row 1 to get a new row 1. And let's see what happens here. So this is 0, -4, -4, -4. The row 1 piece is 1, 4, 1, 0. And add them up and we get -3, -4. Cool. Okay, so let's see. Again, lots of writing here, but we're going to get somewhere. So row 1 stays the same. No, sorry, new row 1. That's right, new row 1. Which is 1, 0, -3, -4. And the row 2 stayed exactly the same. There was no change to row 2. So 0, 1, 1, 1. And you guys talk to me. What do we see? Yeah, now the right-hand side is, this is cool, all these different connections here is on the right-hand side. That is the inverse matrix. That's cool. Okay, got that down. That's cool. So I can do it by formula. I could do it this way as well. Now that we've verified this way, let's try something more fancy. So really, it's just converting this to a identity matrix. The tough one. You guys ready? Elka? Go ahead.
So can this, the matrices method, could that be used with ones that are more than just 2 row by 2 column?
Awesome. Yes. So we don't have to go back to systems of equations anymore. We could just use this one for bigger and bigger and bigger ones here. So let's try it. Here it is, all yours. Give you guys a minute. Yes, you can look at your neighbor's paper as you're doing this. Just not during test day. That's not good. But today you can. So can you guys do this here with a 3 by 3? Whew, I'm gonna walk around for a little bit. I just want you guys to get trying it here. Turn off recorder button here. All right, to start it here. So I think everybody got to this point right here. So redoing this and then putting a identity matrix on that side. So 1, 0, -1, 0, 1, 0, 6, -2, -3, 0, 0, 1. I think everybody got to that point. Is that right? Cool. And then we're going to use that top row. We already have a 1 in its place right here. That's perfect. So now the question is, how do we get zeros underneath here each time? That's where we're at there. And I'll leave that for a little bit.
That's for you.
So let me just kind of show you the first column. You guys go ahead with the next one. So if I have this right here, I'm just rewriting it because I need to see it again. So I could do this twice. Off to the side, what I do is I just say what I'm going to do. So negative of row 1 plus row 2. And I'm going to do that right over here. And at the same time, I'm going to do the other one as well. So when I add this up, here's what I get as answers. Then I say to myself, you know what? I can also do row 1 and row 3. Right? So off to the side, we're going to do that as well. And once that is done, then we can write a new matrix now that has a 1 in the upper right, with zeros underneath it as well. So I'm going to stop right.
Really, you just being inventive and creative. They're just.
Just that one. Okay, so I have this as my new stuff, which is actually on the screen already as well, right? It's this little row right here. So 1, that's the new row that hasn't changed. That's 0, 1, 0, 0. The new row 2 is now 0, 1, -1, -1, 1, 0. We good there? That's the little new row. The third row that is new is now a 0, 4, -3, -6, 0, 1. So that's the numbers we should have got.
I miswrote it, you're right.
Okay. So on the left-hand side of the page, you should see the calculation, and these are just gonna be our new rows, right? Okay. Good.
How do you add the rows without, like, if you have? oh,
Sure.
No, I see what I should do.
Yeah, so notice real quick here, the top row. Good, no problem. That's why I wanted you guys to try it yourself. So your new row, like the row 1 here, we want to keep that the same. Row 1, you can even write it already. And then any multipliers you do to a row that you're not going to change at all. Okay, you guys talk to me. Are we all on at least here?
That is exactly where I am.
Okay, perfect.
And I
Okay.
just need to bring it through, so.
Awesome. So now we're going to work on column 2. So you guys talk to me. What should we do with column 2? To get rid of the 1 on the bottom, and then also we're going to make this guy into a 0 as well. We want the little -1 to become a 0. Okay, so we good. So let me rewrite my matrix. I'm running out of slides. So let me rewrite it. Oh, good. Good, good. Sure, no problem, guys. You guys tell me if I'm going too fast. That's why.
Yeah, you're going a little too fast.
Good.
I'm almost done and I
Oh,
just want to finish.
it's easy, man.
Just want to get the next step.
So intelligent.
Maybe, maybe.
How,
So then-
Ray, how many are done? How many think you got? You maybe
I got
done.
an
Okay.
answer. I
I
don't
only
know
have
if
one
it's
problem. I
correct.
forgot to pay attention to like back column on the last one. So
Uh-huh.
I don't know what the very top column on the other side is, but I got everything else.
Got it. Okay, that's cool.
If you try to like add to the rows, you always have to multiply.
No, not row one is the row that you do not want to change at all. So let's take a look as we go to the next one. Okay, guys, ready?
Wait.
Next
I'm
set.
almost done. I have one more step.
Don't listen to me. So I'm gonna rewrite it. Sorry, I'm just kind of rewriting the previous one.
I was like, suddenly you've got 100.
Let's talk about what should we do. So guys, real quick here, this middle row does not change, true? Because I have the diagonal one going down. We good? So the way I'm gonna write it is this. I'm gonna say row 2, this guy, will be added with row 1 to produce a new row 1. Does that make sense? Because row 2, I don't want to change at all. I have my 1 exactly where I want it. So I want a 0 above this one, and I don't want a 0 below this one. Okay, you guys talk to me. Does that make sense? So I'm working on row 2. Row 2 ultimately on this slide is not going to change. It's going to stay the same. I'm trying to get rid of this little guy right here and that guy. Those guys need to be zeros for me. Go ahead, Joe.
Isn't it easier to save row, like getting rid of the -1 and the top row? There? You do -4 times row 2 plus row 3, then it gets you the 1 there, and you kind of like just add the 1 on top. Makes sense, like
That makes sense.
after you do that step, like if you,
Oh, I see what you're saying.
yeah, like solve
That
the
is
bottom
easier,
one
yeah.
first, and then
That's
it gives you equations that are really easy, just add to each other to get rid of
Because
the
then you have the
remaining.
two zeros.
Exactly, yeah,
That's what I did.
like just.
Instead of doing
Say,
that-
yeah.
Obviously, that's
Yeah,
totally
two zeros
just
and then
like
just a
did
one,
that.
and so we don't have to deal with adding a one and spot with
Yeah.
a one.
Interesting.
I.
But you're still gonna have to do the top row though, right? How, Joe,
Yeah,
how
no,
do you
that's
how-
easy.
Yeah.
Just
Mr. Hanji,
see
then
what
you get a
happens,
new
though.
row
Like, then
2,
you'll see.
then you
Makes
get a
sense.
new row 2
No,
that
that's-
is 0, 1, 0, and then you don't have to worry about ever. So what I did was I first had that at that step, instead of adding there, I instead went in. So I went in, multiplied the middle one by -4, and then added that to the, or added,
That's row 3.
yeah.
Mhm.
And then so I had 0,
0.
0, -1, and then 0, 0, 0, -1, and then I had -6, 4, -3.
Okay.
And then I just multiplied that row by -1.
Mhm.
And so then I had 0, 0, 1, 4, -4, 3, and then I could just add that to row 2. And then I would have 0, 1, 0 for row 2, and then I had 5, -3, 3. And then I did the same thing for row 1 where I added row 2 to row 1. And then I have 1, 0, 0, 6, -3, -3.
Okay, let's see if we right. I'm gonna go with it here.
You
I'm
find
gonna go with my method.
Then you have zeros. then you just add
It's
it
so
up.
easy.
Uh-huh.
Yeah, because if you add row 2 to row 1, then you have to deal with the one that you don't
an
want
extra
there.
one that you don't want. Right? 'Cause it just gets safe.
Gotcha.
Unnecessary.
It saves
Okay. I'm gonna go my way, but if you guys find easier way, let's see if we get the same thing. So now I'm gonna multiply row 2 by -4 to get opposites here. And I'm gonna add it to the row 3 to get a new row 3. And I should get this little guy right here. Cool, so in my schema here is row 2 did not change at all. The new row 1 now is 1, 0, -1, 0, 1, 0. And my new row 3 is now 0, 0, 1, -2, -4, 1. Are we good there? Cool.
Great.
Okay.
Love that.
So the setup now is, I'm looking at row 3. That's the one that's not going to change for me next time. And I could just add it. Oh, look at that. I got -1, -1. So I'm going to add this guy to this one. That's going to produce a 0. Add this one to this one, produce a 0. Let's see where we're at. And let's see if we get the same thing. Real quick here, can I go on to the next slide? Yes or no?
Wait, I'm trying to see where you,
You did a different method, so you're gonna wait till see if we get the same answer as I did.
well, but I already don't have the same answer for the bottom row.
That's not good.
Ups.
So let's go with it. Let's go with it. I'm gonna rewrite, since I'm out of slide space, let me rewrite what I have. This is my row 2 exactly the way I want it. Row 1 the way it was on the previous slide, and row 3 the way it was on the previous slide. Okay, what am I looking at? I'm looking at row, and notice I'm kind of numbering it so that it makes logical sense to me. So row 3 plus row 1 makes a new row 1. Everybody agreed there? Cool. And then row 3 plus row 2 will make a new row 2, right? That's what I want. So 0, 0, 1, -2, -4, 1. I'm going to add it with
That is right.
1, 0, -1, 0, 1, 0, and we get ourselves -2, -3, 1. Cool. Okay, that's row 3 and row 1. Now I need row 3 and row 2. So row 3 plus a row 2 makes a new row 2. 0, 0, 1, -2, -4, 1 with a 0, 1, -1, -1, 1, 0. Add them up. And voila, I have a little answer that hopefully you guys got the same thing. New row 3, the row 3 stays. It did not change at all.
I see where I messed up.
Okay.
Figured it out. I wrote -4, 3, 3, negative, 4, negative.
Gotcha. Okay, the sign changed.
It's just
What?
a
It
lot
was a
of
negative.
steps.
What did you want?
Oh, no, I got it.
And then once you-
Woo! I would love to see it. I did get the same thing. I cannot believe I got that right.
Exactly. It's
I
just
had
like-
an attack.
it's so interesting. If you don't get that, then if you mess up one
I don't know
step,
how I got
then
my math
everything
wrong.
is wrong.
goal.
So it's all just the long history.
Wow.
Say again.
That's one in 50
Hey,
I don't mess up.
Noah has a little question. It's interesting. Noah asked if this is just a process. And remember how we did the systems of equations by calculator? Yeah, how we had 0, 1, 1, 1 down the diagonal. We did this by calculator, didn't we?
I don't, yes.
We can make this by calculator. What was the little thing majiggy on the calculator? What was the command on the calculator? RREF. It's called row reduced echelon form. Oh, I think that we can't do the ... because we didn't do the ... on the previous one. But what's the size of this matrix? No, it's a 3 by 6, huh? 3 row, 6 columns. Let's go with it. How about this? Next slide. Let's do this by calculator. So yeah, get out your calculators. Let's see what we got.
High school sweetheart helped me for 5 years.
Only 5 years, we get gradually divorced.
And let's see if we get the same thing.
What's wrong with the stuff that drove apart the road? Because clearly this has to until the third child, it was the third child's issue.
So let's see how we put this in. 3 by 6. So the way you're going to put into our calculator is going to be -1, 1, 0, 1, 0, 0. 1, 0, -1, 0, 1, 0, and 6, -2, -3, 0, 0, 1. So that's how we're gonna have to put it in, and eventually. Sure.
Good, sir.
And if you guys think you're confident enough to do it yourself in the calculator, go for it. Try to do it. Put it in. It's gonna be a 3 by 6 matrix.
I'm just really thriving right now.
I left my calculator in the house. I'm sorry.
That's okay. It's recorded anyway, so if you ever want to see it.
Yes,
Yeah, that
because
would
you may have been
all that.
mistaken.
Sure. All right, class, let's go for it.
Because I can't tell where I went wrong, because I'm still getting the wrong answer.
Uh-huh. All right, here's our calculator. Those with the calculator, let's try it. Hopefully it'll be a lot faster.
So,
Ready? This little matrix button right here on top of x to the negative 1 is super duper important. And we always go backwards. We always go from right to left. So first things first, we got to go and edit. We have to go and create our matrix. And I'm going to use A to create my matrix. So I'm going to use matrix A. This time it's going to be a 3x6 matrix. Click enter. It's going to give you a whole bunch of different setups. I have, you probably will have 0, 0, 0s everywhere, right? I have this thing. So let's go with it here. So this is 1, -1, 0. Ooh, notice it says row 1, column 4, right? So it kind of tells you where you're at in the process, so you don't lose. So this is 1, 0. The other way that you can guess, when you click in this extra 0, you're going to jump to the next row. Now you know that you finished up that row. So click, and it jumps you to the next row. So now I'm on row 2, column 1, 1, 0, -1. I'm on my identity matrix now, so 0, 1, 0. Click enter. I'm sorry, Hawk. 6, -2, -3. This one's gonna be a video, so that'd be cool. So this one you can go back to it. 1, 1, 0. Oh, sorry, 0, 0, 1. Click enter. Now, when you click enter and this one is solid, we're gonna click X. We're good?
He's gonna get crippled. They're gonna be- that's what
Yeah,
he's
the
gonna do. They're gonna be crippled brothers.
oh, you spelled it the wrong thing.
Oh,
Did you
quit,
do
yeah.
it after you entered the cell?
No,
I
no,
did.
they're not gonna
And
do
then you went
suicide.
back to the matrix and you-
Okay,
and
back to
when-
matrix.
Together.
Yes, but
By going into a lock
they
room that
just
was
really
opening like
hates
the
me.
hatch.
And we're going to the math menu. So it's always from edit,
I
math to
don't
main.
know what
You always go
I'm
backwards.
supposed to be doing.
Joe, what in the world?
Guys, real quick
What are
here.
you guys talking about?
I don't know.
I'm sorry, I'm attempting. to
1
learn.
second. 1 second, guys. Okay, math. Math, you're gonna go down all the way to RREF, row reduced echelon form. Trivia question, what in the world does that even stand for? What does echelon stand for? There is a specific thing. So if you ever want to know, go for it.
It sounds like the last name of someone.
Last name, maybe. So let's go with it. RREF. And then you're still gonna go back to the matrix menu because you're gonna name it now. So you want to, so I want the RREF of matrix A, the one I built, which is A. Click enter. Close off the parenthesis and let's see what happens. And mark it, set and go. Oh, I don't see all of it. That's no fun.
Very wrong.
Mine shows all of those.
Yours shows all of it. That's cool.
Yeah, right.
So what you're gonna do here is we're just gonna use the arrow keys.
Then you
And
go
question,
back-
do we get the same thing?
you
Awesome.
go
Cool.
back to matrix, and then I click C.
Lot easier? I think so. I think I like the calculator method. So -2, -3, 1.
I don't know.
-3, -3, 1, -2, -4, 1.
Oh, because oh, sorry.
Okay, we good? I'm gonna jump out of here to write my answer. My answer by calculator is this right here. And love it.
Very strange order.
Uh-huh.
If you like restart it.
That's what I'm hoping.
I like this calculator.
Okay, so
Okay, one more we gotta do is we're gonna put the whole thing together.
One on top of row, like if you want row, a new row 1, you have to put row
I
1
figured
on
it
top
out.
or bottom.
Did you look for is it close the parentheses or something?
On top if you want a new
That might
row
have been
one.
it. Also, I was
That's
waiting,
what I did.
which I
Mhm.
think was a
On
problem.
all
I think
of
you're
them,
only
I
supposed to
put
put
the new one on the.
Underneath, gotcha.
I mean, I
Yeah.
can't really put anything else. This is the only thing.
All right, class, we good?
Yeah.
One more. Let's see, that's the 3x3. And the question is, how does this even help us with stuff? So I'm gonna kind of put two things together. So first things first is, I'm gonna say this. I'm gonna say, first of all, find the inverse of this guy,
I hate it here.
OH. And then we're gonna somehow find, knowing the inverse, we're gonna find Whoa, what is that?
4x4.
That's a 4x4.
I mean, you can 4x8.
So how about this here? Talk with your neighbor. If you have a calculator, can you guys do this by calculator together? We're good? Go for it. So just find me the inverse first. And it's going to look kind of funny. I think on the TI-84s, maybe Noah, I'm going to see what your calculator says, but we should sort of see a little funny something where it happens there. So first things first, find me the inverse matrix, then we'll have a little discussion. So you are going to create a 4x8 matrix, is that right?
Oh, yeah.
Because you want that identity
My
matrix
math
on one
is.
side. So those without a calculator, you're going to be patient with the people that do have a calculator. And if you're confident, go for it. If you need help with your neighbor next to you, do that as well.
Oh, that's.
Is that an
numbers.
11 in the?
That's 11. 11 on the bottom.
One.
Here, I'm writing out the identity matrix. So we don't mess it up.
One. Second. Wait.
There you are.
That's stupid.
Yeah, I'm curious because Mike calculator gave me a funny answer a little bit here. So
What?
I'm not getting
I
it.
thought it was where it said it.
I'm going to start myself as well.
Should we just?
Oh, yeah, it works so weird.
4x4.
Whoa, what's going on?
No, but then you.
Oh.
Why do they have a negative 2.3 negative 12?
Oh yeah, how fun is that? That's cool.
Oh, yeah, that's really helpful.
Okay, for the video, I'm going to put it into the calculator as well. 1 second, trying to figure out the screen. Okay, show taskbar. Okay. Abby, what you don't see?
No.
Uh-huh. So I'm gonna go this way, clear, quit. Okay, this one. Okay, I'm gonna go matrix operation. And let's me, I'm gonna label it as F. Are we good? This is gonna be my F matrix. Oh, sorry. My messed up. Matrix, edit, you got it. Edit, F. It's gonna be a 4x8 matrix. Oh boy. It's 11 on the bottom, 1, -2, -1, -2, 1, 0, 0, 0, 0. That's, oh, I'm off. I know I'm off because -2, -1, -2, 1, 0, 0,
Like, that's the thing that
0.
I do not know.
Okay,
1, 2 minus 2.
3.
What did I do?
0 minus
Well, let's go look, I guess.
0.
I guess.
0. That's
-3. So this will be a 0. This time 1.
X
0,
the 1 is
0.
X the 6 is 1. X to the third is 0 and X to the fourth is 0. I have no idea what the heck is going on.
Okay, 0, 0. I'll come by in just a second here. Let me punch in my numbers here, at least get the answer. -1, 4, 4, 11. Then it'll be a 0, 0, 0, and then 1 finally at the end.
Because my head doesn't do a 90-degree turn to look at Luke.
What did I do?
Because you're doing like the where you tap your nails on the table.
No, I had a plan.
He's filling out a 99 by 200 matrix right now.
All zeros.
Okay, let's go with, I'm gonna go for it here. Math menu. And this is the F matrix. All right, you guys talk to me. Let's stop here.
Why is
What did you guys get?
Weird.
Mine on my calculator?
No, why does it have this? I'm so sorry. We both have these.
Oh, yeah.
For the improvements with the second tour. No, literally, there's pictures of it. And I just have like.
So let's look up here real quick, guys, real quick. So as I scroll across, I get
Yeah, see, what is that?
that
Why is it
guy.
I completely thought that I just did something weird, but
Not
not.
fine.
So like,
I am a genius.
can you just like,
So where's that?
never mind, I just.
I know.
All right. First of all, let's see what that number is. Negative 2.3 times 10 to the negative 13. So question is this, first of all, what does that number look like? That is negative 2.3 with 13 decimals to the left. Is that right?
Oh,
0, 0,
So it's
0,
like-
0,
it's like
0, 0,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What is that number very, very close to?
It's very close to not even being a number. Can we just round it to 0?
I think that's pretty close to 0. Is that right? Yeah. The way a calculator does this, it computes it by decimals as opposed to by kind of like numbers, right? So it tries to figure out, it'll just do one at a time. So it just kind of goes through the list, it processes it, and sometimes it does this right here. Sometimes it does it by graphs as well. And I'm not sure, maybe even does it by pixels as well. That's why it kind of strange answers. But whenever you see something like that, it's pretty much 0. We good? So let's rewrite this here with a little bit of time left. Can we rewrite it? This is what I started off with. Is that right? This is what we entered into our calculator. And then what we got an answer of in our calculator was something that looked like this right here. So let me go back to the calculator to make sure I got it. So I'm going to go by columns because it's easier to do by columns. So if I go back to the beginning here, I got myself a negative 24, negative 10, negative 29, and 12. Are we good? Column 1. Column 2 for the inverse matrix is 7, 3, 7, negative 3. This one would have been then 1, 0, 3, negative 1. And the last column should be a negative 2, negative 1, negative 2, 1.
No.
So there's my new identity matrix and my final answers going down. Are we good there? Okay. Let's see. Let's talk about this. Did we've done logs already before, is that right?
Yes.
Yeah, so let's have a little conversation here. So whenever I'm going to do this one right here. Let's see. If we have something looks like this, e to like the negative, e to the x, right, is equal to 3. What did we do? What did we do to solve this? You guys remember? We put an ln. Yeah, so this became, this became this. And what happened was that these two would cancel off because they're inverses of each other. Is that right? X became ln 3. So let's see if this makes sense, guys. If I have, guys, real quick up here. So if I have a times x is equal to b, what I can do is I can put an inverse on both of these guys. And I do this right here. Inverse of a times a of x, inverse of a times b. Are we good there? I stuffed an inverse on both sides of my equation. What's going to happen to inverse a and a?
Cancel.
They will cancel out. And I'm left with this right here. So now I'm done. So did I solve for x already?
Yeah.
Absolutely. So let's see how this works out. Let me jump back to the previous slide. Okay, this is kind of like a logical inference of things here. So if I jump back to here, you guys talk to me, think with me. If I have, this is my matrix, and notice notice the numbers here. Notice that one right there, it goes to here. Hey, these are the same exact numbers. -2. I'm just missing this little piece right here. Good there? So isn't this the same thing as this? Isn't this just coefficients? I know we did this on Monday here. It's coefficients times x is equal to my b value. So let's see if this makes sense a little bit here. Do you guys remember on Monday, we had a 2 by 2 matrix and it was like this. Let me give it to you. So it was like this 1, 1, 2, 3, 4 times, and this was x times y or x1, y1. Do you guys remember that from Monday's class? Maybe, maybe not. We'll see.
Yeah, as soon as you started getting to the point where you were writing the numbers in the lower right, it just gone.
Gone, okay, okay. So let's do this here.
I comprehended like 5% of that, and it just.
Okay.
went down.
Then we go from here. So if I have a matrix multiplying all my variables, which is equal to some kind of number at the end, all I have to do to solve it is just find the inverse of it multiplies the b. So let's see, how does that apply to matrices here that we have? One second, let me get rid of this here. So here's what we're gonna do. We're gonna take this inverse matrix that we just found, and we're gonna multiply it times, let's go back real quick here. We're gonna multiply times these little numbers right here. And let's see if we can first. So we're gonna build a matrix called 0, 1, -1, 2. Are we good? On the next slide. So here's what we're gonna do. Oh, sorry, there it is. Let me go really, really fast. So I got this right here. I'm gonna multiply it times 0, 1, -2, -1, 2. First of all, can I multiply it by that? Am I even allowed by multiplication to multiply? Well, this is a what? By what matrix? Oh, sorry. This is the first one. 4 by 4 matrix. The next one. Row columns, right? Row, 4 rows, 1 column. Am I allowed to multiply these guys together? Yeah, I am allowed because the column of my first one matches the row of my next one.
Oh, I forgot that's the one.
And then what's going to happen here? What's the equal sign going to be? Equal sign is going to be a 4 by 1 column. That's what it's going to end up because we only have 1 column to multiply with here. So real quick here, can we enter this by calculator? Because I don't want to multiply this out. Can we enter this by calculator? So some work ahead of us here. Come on, where am I at screen? All right, I'm gonna go kind of fast to finish on time here. So clear. What do I need to do? I need to create a matrix. This one's gonna be a 4 by 4 matrix. So go to edit. And it is a -24. We've got to enter this guy now. -24, 7, 1, -2, -10, 3, 0, -1, -29, 7, 3, -2, 12, -3, -1, 1. Are we good there with that one? Good there? That's the inverse matrix. Got that one. And then we're going to create a 4 by 1 matrix just with 0, 1, -1, 2. Okay, everybody good there? Everybody created the 4 by 4? I feel like I'm in and out. 4 by 4. So matrix, let's go to the next one here. B, my B matrix is going to be, oh, sorry, real quick. You got to edit it. B, edit, B. B is going to be a 4 by 1 matrix. And it's going to be 0, 1, -1, 2. There it is, and quit out of that. And all I want to do is I want to multiply, right? No RREF anymore. It's just a multiplication between the two matrices. So matrix A times matrix B. All I'm going to do is go back over here. I'm going to put second matrix, and I'm going to call out the B matrix. And I'm going to multiply. Dude, 2, 1, 0, 0. That's what I got. So answer is so real quick here, if I go back, just go back. So then I know my x1 is equal to 2. X2 is equal to 1. X3 was actually 0, and X4 was 0. And I've solved it. We good? Good. We got to the end of the inverse matrix. Oh, Friday, we get to do something called the determinant. That's awesome.
So 8.2 is Friday.
8.2 due Friday. All right, guys. See you guys. Have a good day.
Or you just not reading your test.
Yeah.